Okay, so remember last time we looked at a lot of different things about polynomial graphs. So I wanted to start today with finishing up that. No. Yeah, did we stop with example 5 last time? Yeah. So yeah, it's a new problem. Okay, so we're going to run through all the things that I want you to be able to know how to find with a graph. So the first thing that you have to know is kind of what the graph is going to do at the ends. Remember, end behavior means the far left and the far right. Okay, and we can tell what the end behavior is based on 4 cases. We talked about this last week, but we need the leading coefficient and we need the degree. So the leading coefficient, notice this one is different, right? Notice it's all kind of already mostly factored out for you. So I'm going to start with the degree. We have a third power something and a squared and a squared. So what would happen if you did a third power times a second power times a second power? What would be all of those powers added up? 7, right? 3 plus 2 plus 2. Okay, 3 plus 2 plus 2. You just add all the exponents. The part about that that is significant is the fact that it's odd. Okay, we want to know whether the degree is even or odd, and then we want to know whether the leading coefficient is positive or negative. Okay, so notice here, all of the numbers in front of the x's are 1. So if you were to multiply them out, which we don't want to actually have to do, it would be 1 or positive. Okay, so that means we have a graph that, this is case 1 from last week. The graph goes down to the left and up to the right. Okay, so I'm just going to remind you of your notes from last time. You just need to look at the 4 cases. Okay. All right, so let's run through the various other things. So let's find the y-intercept by setting what equal to 0? What do you always set equal to 0 to find an intercept? Well, the other variable, right? So in this case, it would be x, right? So we just need to set x equal to 0. So we get 0 cubed times 0 minus 2 squared times 0 squared minus 4. Honestly, it doesn't matter what's going on in the rest of it, because what is this 0 here going to do to everything? It's going to make it 0, right? So it would be y equals 0, or if my lab wants you to put it in point formation, then it's just 0, 0. Okay, I'm going to kind of circle the important information from each step. The third step is to find the X-Intercepts. So remember, I'm going to put a star by this one. This is going to tell us the most pieces of information. To find the X-Intercepts, we set y equal to 0. So try to realize that some of the work's already been done for you, so we don't want to foil this bad boy out here like it's already partially done for us. I say partially because maybe we could factor this guy right here out a little bit more, but everything else is already done for us. So how could I factor the x squared minus 4 out a bit more? This was on your competency exam. It'd be x plus 2 times x minus 2. It's a difference of 2 squares. Okay, so notice how many parts do I have here? Well, 4 counting this, right? And we do need to count this. So let's start off. So first we have x equals 0. The multiplicity here is 3 because of the cubed. So x occurs 3 times. So what does that tell us because we have an odd multiplicity? Does the graph cross or does it turn? Okay, it crosses. So there's one x-intercept. So now let's look at this guy. Okay, what would be the x-intercept here? X equals what? 3, right? If you set x minus 3 equal to 0, you'd get 3. How many times does that one occur? Like, what's the power there? 2, right? Which means it's even. And what do we know about multiplicities that are even? The x-intercept will not cross, but it'll do what instead? It'll turn, right? Cross and go through are the same thing. So crossing and turning. So if you want to say that, you can say go through here, but turns is its own thing. And then lastly, we have these two, right? This is, the first one's -2. Notice there's no power there, so what's the understood power? 1, which is odd. So the graph crosses through the x-axis because it's odd. Same with the last one. That one only occurs once. So the graph crosses there too. So the next thing is we're supposed to find out if there's any symmetry. Okay. This is where you find out if it's even, odd, or neither. I'm really only mentioning this because my lab does. I'm not really that concerned with symmetry because symmetry helps you occasionally. Most of the time it's not a big thing. Okay. In other words, if you multiplied this out, you would have a combination of even and odd, so it is neither. All that tells you is you have no symmetry. If it's even, odd, or neither. Okay. So for this one, I don't want to spend the time actually working through it, but you would multiply all of these things out and you would get a combination of evens and odds. So that's why it's neither. All right, so then here is the big important step. So you're supposed to graph all the info you have and then see if we still need some things. Okay. So we're going to come up with a graph maybe that goes out to 5 in every direction. And then if we need to go bigger, we'll make note of that. So what I want you to do is, move that up a little bit. What I want you to do is graph what you know, and then we'll see if there are any gaps in what we know. Okay, so they're not all on screen, but I just need you to be able to kind of go through. So it crosses the y-axis there, right? Where all does it cross the x-axis? At 0, but also where? 3, at 2, and at -2. Okay, and we actually also know that the graph goes up to the right and down to the left. And we know something a little bit more, right? We know that it goes through here. I'm looking up here at my third step. I know that it does what? Actually, at -2 it goes through, right? At 0 it does what? Yeah, 0 it also goes through. You can say through or crosses. At -2 it does what? Or at 2 I mean. So 2 it crosses also. The only one where it actually is supposed to turn is where? At +3. So let me rewrite that because it was super sloppy. Okay, so I definitely have some additional points to pick. So I just want you to kind of look up here on the board. So this is essentially what the graph does. It comes up here, some height, I don't know, then comes back, right? And then it goes down here because it goes through there. What does it do here, according to what we labeled? It goes through again, right? And then it comes back and then goes straight back up. Okay? So we kind of need to know what? How high this is, how low this is, and what? How high that is, right? So when you go to pick your points, you pick points that make sense for your problem, okay? What we need to know about is all the places in between the x-intercepts that we have. So when you get to picking additional points, my lab might pick them for you, but on a test, they're not going to be cookie cutter, and you're going to need to be able to graph what you have and reason out what you still need, right? So let me point right here. Okay, let me erase what I had up there. What would be good between 0 and -2? What would be nice to know about between 0 and -2? -1 would be nice to know about, right? That would catch in between here and here. What about here? I'd like to know about in between 0 and 2, so I'd also like to plug in what? +1. And then here, notice I have 2 and 3, but I don't know what's happening in between them, so what do I need to pick there? What's in between 2 and 3? 2.5. Okay, so you're going to plug all of these in. Okay, so how do you get these y values? You plug them in the equation. Say again?
Where
I'm sorry, I don't know what you're saying.
You know how you said like the X is 2, right? Like one of the X-Intercepts is -2 and 2?
I marked those, didn't I?
Yeah. It was supposed to be 4, right?
No. Look where we factored out. We did a difference of squares here. 2 and -2 is what they were supposed to be. Because it was x squared minus 4. It wasn't just x minus 4, so I see what you mean. All right, so if we plug these in, these are the values we get. This one is 48, quite high. Okay, so I don't want to waste too much time going through there. If you plug in 1, you're going to get -12. If you plug in 2.5, you get 8.79. So what does that mean about here? It goes up super, super, super high, right? So do you want to count up to 48? I don't want to. So what are we going to do to kind of fudge it then? We're just going to do this right here. We're just going to say, hey, up here's 48. Just label it so that I know that you know it went high. You don't have to actually count up to 48. That's not reasonable. Okay. So did you see what I mean by fudging it? We're just saying, hey, this is 48. It represents how high it goes. And then what about here? It needs to go down to -12, so you can do the same thing down here. It's not quite as low, right? But I don't want to count that low either. So -12 is here. And then 8.79, here's 5, 6, 7, 8. So it's just a little bit above that. So do you see how you can still kind of generally tell me that you know what the shape of the graph is, even if everything's not perfectly right? Okay. So notice the height is a lot higher than I'm showing because it actually goes up to what? 48, but I showed that here by stating that. Okay. It goes down actually further than I showed because it goes down to -12. So all I really want to see when it has really high maxes and really low mins is I just want to see that you wrote it in there. Okay, and then we can put a note here if we want to, note that the graph is not to scale. That's what it means when it says not to scale. It's not drawn, quote, correctly. Okay, so I don't want to just drive this point home, but when you do these on your homework, when you look forward to test 2, what you're going to have to be able to do is find each of these individual steps. In other words, I might say graph this equation by finding the end behavior, the y-intercept, the x-intercepts, and additional points if needed. So in other words, like, you don't have to memorize the order of these steps. I would list out what I wanted you to find, but you still have to be able to say, hey, if I need the y-intercept, how do I do that? And what's the answer? How do you find the y-intercept always? Set x equal to 0, right? How do you find the x-intercepts? You set y equal to 0. So don't focus on memorizing the steps because that's not really super important. Just focus on learning how to do each individual step. Okay, so I would give it to you in some sort of listed format. Okay, and then the last thing before we move on to something else is, how do you know which additional points to pick? You don't know that until you do what? Graph what you have and see where your gaps are, right? Like, I need to know what's happening between these 2 points, so I'm going to pick the point in between them. So there's really no cookie cutter way to do this the same way every single time. You're just going to have to graph what you have and see where your gaps are in order to know what additional points to pick. Okay?
You basically put the points in our calculator.
You can, yeah, I definitely would for one like this. Yeah, so for sure.